After doing lots of tests on equalization and compression, I've come to the conclusion that my vocal chain in terms of the electronic chain is perfectly adequate as it is, and it doesn't need any alteration. So my compressors work perfectly well. The gain that I actually put into OBS has been turned down by about 3 dB, maybe subtle difference, and that's just a volume thing. And that's because I've given more gain to this microphone, and that's about it. The thing I want to do in this particular test isn't actually test whether or not I need more gain or more compression or more EQ. It's whether or not the saturation circuit, which is new also, works well or just sounds weird. So up until now, every single show's had what's called the 4K circuit from the SSL2 desk engaged. On this recording up until now, there is no 4K saturation. So in a minute, I'm going to pause the recording, turn on the 4K button, and then see how that sounds by comparison. Same volume, same distance. This is how the microphone, which is the Neumann KMR 81i, sounds with the SSL2's 4K saturation circuit engaged. So I'll talk a little bit about what it is and what it's supposed to be replicating. The old solid state Logic 4000 series desks from I think the 70s had a certain sound to them, and that's the analog distortion or saturation that they would put in. So what's saturation? It's a type of distortion that essentially puts other sympathetic frequencies within the harmonic range of whatever you're recording on top of the recording. So it kind of adds a kind of fullness to the sound, and it's not distortion that's bad in the respect that any distortion is a deviation from the original signal, but when it's sympathetic and harmonic, it can sound very pleasant. So that's what this is doing. It's putting a sympathetic distortion, there's no other way to put it, onto the top of the sound of my voice. So this is the SSL2 plus 4K saturation circuit engaged. 4K meaning 4000 series desk replication, I guess. But it's a little button on the processor that I just press, and it turns on this saturation. So this is how my voice sounds. The other thing I'm going to be testing today is whether or not having the mic completely horizontal at my voice. That's to say that the mic is pointing directly at me and it's straight on horizontally. So this mic, again, KMR 81i by Neumann, is pointing directly at my mouth. It's at a 45-degree angle, but only in one axis. So obviously you can have it at 45 in both. In this case, it's off axis, pointing at the corner of my mouth, but horizontal to my mouth. And this is how it sounds. In a second, I'll pause it and we'll get back to the unsaturated, that is to say, non-4K signal path, and see how that sounds. Back with the 4K circuit disengaged, and this is how my voice sounds without the 4K circuit. So Neumann KMR 81i short shotgun microphone. I should do some plosive tests, as I suppose having it at 45 degrees in both axes, horizontally and vertically, does limit the chances of putting a plosive down the microphone. Whereas if I am actually looking at the microphone and I present a P to it, there is a mild chance that enough air can get through the end of the front of the microphone. I hesitate to call it a capsule because that's further down the microphone's tube, but I'll do a quick plosive test. So please provide pizza pronto, bottom of the barrel. Please provide pizza pronto. I'm looking at the lights on my desks, so they're all roughly on the monitor. I've never actually done this. I could actually swing this round and show you what's going on here. So this is how I see things. I don't think I've done this before. So over there is my window, which would have the screen and typically the projection of my guests and everything else. But this monitor has my OBS stream and this banana, this desk. So that's how I keep an eye on all of the guests' lines for audio. So spin this back around. Oh, which way does it? Which way does it want to go? Oh, that way. There we go. Slightly confusing. So let's put that back here. And I think that's going to pretty much conclude the test. Me leaning forward past the microphone is going to do a pretty good off-axis presentation of what the mic will sound if I'm leaning past it. Oh, it's because I'm supposed to go past the monitor, that's why. Things that sit in certain places when I'm pulling all of this stuff out. So you could probably see that the monitor is at a weird angle. That's because I pull it out of the wall where it's tucked in behind a piece of acoustic treatment. And then the mic goes away behind me. The camera goes behind the TV. The lights and everything are attached to boom arms. They slip away with all of that. So when I put all of the cameras and lights away, turn everything off, it turns back into a lounge. But once it's actually set up, everything's pulled out. It's a fully fledged studio. It's fully acoustically treated. Anyway, that's probably enough time on the unsaturated 4K circuit. So I'm going to swap back one more time to the 4K circuit to see how that sounds. Back on the 4K circuit engaged, and this is how the Neumann KMR 81i microphone sounds with the solid state logic SSL2 plus 4K saturation circuit engaged. And this is what it sounds like on my voice. What was I talking about before I swapped over? Probably acoustic treatment and how nice this room sounds, how dead it is. That being said, I do have Clover in the next room listening to her iPad, so it is a reasonably good test for the ability to cut out noises that aren't directly on axis with the mic. Now this particular mic, which is a short shotgun, there is a different version called the KMR 82i, which is about double the length, but this particular mic has about a 90-degree pickup pattern from the mic itself. So what I'm trying to achieve is being obviously perfectly on axis with it is ideal, but not wanting to have any chance whatsoever of putting plosives into the mic and needing to be able to see past it. So as it sits, it is blocking the monitor, but because it's a very widescreen monitor, it's in a position where it's only blocking a section that isn't used very much, as in it hasn't got anything on the monitor. And as I look at the mic, I'm then very, very conscious or acutely aware of whether or not I'm putting plosives down, because I'm looking at the level meter as I look at the mic. So it makes me that little bit more aware of how I'm dealing with the mic. If I'm yelling and looking at the levels while I'm looking at the mic, it does make me that little bit less likely to yell down it and make it distort. So with this particular mic, I have turned up the gain slightly. So it was at 10 o'clock for the NTG3B. Now we're at 11:30 on the gain meter on the SSL2. So it is that little bit louder. As I say, we're currently running with the 4K circuit. From what I could see, not hear, previously when I was doing these tests, it seemed like it put a bit more average energy. That is to say, there is more to the signal. Therefore, the average of the signal is a little bit higher on the meters. So I haven't been glancing at them because I like, obviously, to look at the camera when I'm doing this. It's a little bit unnatural to be looking at something else as I'm talking, but I'm going to do that now. So I'm going to look at the level meters and describe what they're doing. So currently we're coming in, or I could just actually put this on screen. That would probably be a more sensible way to do this, so you can actually see what I'm talking about. We'll it up. There we go. So if I bring over voice meter, you can see this level in the bottom left-hand corner now. That's what I'm talking about. So this one, this level meter currently is sort of going between -30 and -25 approximately with the 4K circuit engaged. So I'm going to pause the recording, turn off the 4K circuit for the last time, and we'll see how that sounds. This is the circuit without the 4K engaged, and I don't know, it kind of seems to be coming in at -25 still, so maybe it was a misapprehension or me talking a little bit louder or quieter when I last did this test. Although in saying that, it does seem to seem 1 or 2 dB quieter, which does kind of make sense because it is an actual analog signal path that it goes through to put the 4K circuit into effect. It takes the signal, runs it through an analog circuit, and then back out, and then into the DACs presumably, or ADCs I should say, going from analog to digital to go into the computer. So that's what's happening. I can only assume that that would add a little bit of extra energy, and therefore now I'm not getting to -25. I'm hovering between -25 and -30 at the peaks of my voice in the averages. So that's this little black line in the middle that I'm talking about, as opposed to the peaks. Now the peaks are controlled by compression, so it makes no real difference what happens there, other than occasional transients that can get through, like a door slamming. My wife's just closed the door as she's walked out, and the snap of the catch of the door, that transient can actually get its way past the attack stage of the lower compressor. So it's one of those that it doesn't seem to, no one fusses about it, or it's not something that's going to cause any complaints. But it is the case that I don't have a compressor with a fast enough attack time to deal with certain transients. But if I could just turn it up, but if I did so, let me show you what I'm talking about. Again, I shouldn't really be discussing these things without actually showing you what I'm on about. So in OBS, you can go to filters, and in the filter section for the compressors, let's just go into one of them. There's an attack time, so you can lower this down. It only goes down to 1 millisecond. Now there are professional outboard or analog compressors that you can put much faster attack times on. Anyway, the point being that certain transients you just can't grab quick enough. But me, with a voice being the main thing that's going into this microphone, it doesn't really matter. I do two-stage compression, so this is the more severe of the two compressors. It's very late, relatively late, at minus 14 dB and 6 to 1. But there's also a milder compressor that works at 1.5 to 1, and that starts at minus 20. But again, it's got an even more relaxed attack time at 30 milliseconds. And the only other thing that you could call a compressor, it's strictly not, it's obviously above 10 to 1, but that's this limiter that I also use, and that just kicks in at minus 2 dB. So that's pretty much it, other than EQ, which again I could put in this video just for the sake of having shown it. And that's this. So this is my EQ. I don't know how much that compressor actually showed on screen. I might bring it up again because it's looking now where this is situated. Obviously a high pass filter, low pass filter, and a dip to engineer out the very steep rise in treble frequencies you get from this, because it's a shotgun mic trying to pick out sounds from the distance, which will lose treble along the way. So that is being compensated for by this dip. Takes out some of the sibilance S sounds. And that's the EQ that I use, and I will just, for the sake of making sure it did actually make it to the screen, put this over here. There we go. You can see what this is going on now. Hopefully it's all on screen. There we go. So those are my compression settings. That's about it. I'll round out there. I've been Nathan Oakley. See you all in the next video.